In this video I'm going to show you how to set dynamic and static shading on your building. Let's start with dynamic shading and let's toggle the simulate solar to false for now to save computing time, so when we change things. Generally you have these two kinds of shadings, static shading and dynamic shading. And dynamic shading you can set in the buildings component by opening the form with a double click, and then you go to envelope, and in the Windows section you will find parameters for the G value total, and the shading set point. And what that means is when this set point is exceeded on your window on an hourly basis, then a sunscreen is activated, changing the G value of the window to this effective G value total, which includes a sunscreen. And we can see what difference that makes to the solar gains if we keep the G value identical for both cases. So there's no button for deactivating dynamic shading, but practically this is deactivated because we have the same G values. And now if we compare the solar gains through the windows here, so yeah, let's look at this section. And now we change, we give it a dynamic shading that is activated at 200 watts per square meter on each window. So let's set it to 0.1. Then you will see that it significantly reduces the solar gains because the sunscreen is always activated when this value is exceeded. And you can change these parameters, and you can study how that would impact your solar gains. Alright, the second option is static shading. And static shading has a geometric representation in your model. So you do model it as a mesh, or it needs to be provided as a mesh, and this one is an old component, so we can ignore that for now. But let's give those two windows now static shading, and let's do some fast modeling. Bake this so we have the geometries. Actually, no, let's bake this, and let's just give it an overhang, I would say. Doesn't need to be perfect now. Alright. And this one maybe too. Get something. Oops. Well, this won't do much. So let's rotate this maybe. I actually do need this. So now we can rotate it. Whoops. Set this as plane. Rotate 2D. Yeah, that works. Maybe like that. Okay, and we don't need this anymore, we don't need this anymore, we don't need this anymore. And the static shading, it doesn't have to be solid, it actually can also just be a surface. And let's just do both for the sake of it. So let's make this a solid. Really thick overhang. That's better. And this one remains a surface. And then we set this. Set that. And as I mentioned, these need to be meshes, so we just put them into a meshing component. Hide that. hide that, and we see our meshes here. And the static shading needs to go into, let's make some more space, needs to go into the environment object, because for the simulation, it is nothing else than just an obstacle. So we do that by clicking here with the left mouse and keeping shift pressed. You see the little plus sign appearing, and add it to the other obstacles. And that's it. Now you still don't see any impact on the solar gains, and that's because we didn't simulate the solar gains. So let's hit on true on simulate solar, and you would see that the solar gains changed a bit. So here it's entirely shaded, which you see by this color being entirely blue almost. And you know what, let's hide this building, also the windows, so it looks a bit better. Yeah. Right, and now there's one issue that you can already see. Let's also hide the city. Yeah, that's better. And that is related to the discretization of the window. So in certain cases, when you have very detailed static shading designs, you might want to increase the resolution of what you're simulating. And right now, we're actually just simulating 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So on each of these vertices, on each of these points, we are calculating the hourly solar gains. And we can increase that to a finer resolution if we need to, but of course you should only do that if it's necessary for the simulations to save time. And you can do that by adjusting these U and V parameters of the window surfaces. So we can increase that to something reasonable, let's say 10 or something in V direction, and you would already see that the simulations take a bit longer. And of course, the higher your resolution, the longer your simulations will take. And this was actually in the wrong, or in one direction. Yeah, you can see that we now have 10 more, or we have 10 points into that direction, and only 2 or 3 in that direction, and 11 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah. So we can do that to a 10 times 10. And it gets much slower, and depending on your computer, this might take a bit longer or shorter. Okay, so now you see a result for a 10 times 10 mesh. And yes, depending on the static shading that you design, you will want to refine or reduce the resolution of that calculation. Also, for simplicity, you should work with rectangular windows for now, but if you really wanted to do more fancy window geometries like that, you would need to sort out yourselves how to mesh that, or how to discretize that into a proper mesh. So currently, the meshing that is happening is with the native Grasshopper component. So you can, if you click on these buttons, on these parameters, you will find where that connects to, this U and V direction discretization, and it goes over here, and that's really just a simple mesh surface component that takes a surface, takes U and V, and turns that into a mesh. And that would not work with more sophisticated surface geometry. So if we had this as a surface set, and put that into here, and have a look what comes out. Yeah, that's just yeah, that's just a bit weird. I mean, technically you could put it in to your model. Let's do that for now, as a test. So some polygon. Okay, now I have simulated this window, and you already see that the discretization is a bit funny. So if you wanted to make that a bit better, you could go over here and replace that component where it turns the surface geometry into mesh with something that you define yourself. And it could be, I don't know, something like Voronoi or Delaunay triangulation, so anything you like. But what is important to know is that you need to turn the surface geometry into a mesh for simulating solar irradiation. Yes, and that concludes the static and dynamic shading video.